If you guys are ready.
Okay, ready to go?
Sure, great. So first off, thank you everyone for joining us. Whether you're joining us from Zoom or live in person, I'm sure everyone here is very glad to meet the founders of Tangram. I know that the event was originally advertised as a workshop, but we've kind of changed the format to be more of a fireside chat with our lovely founders here. So if you guys could first introduce yourselves and tell us a little bit about Tangram.
Yep. So I'm Isabella.
I'm David.
I was course 6 and course 18 in 2014. A very long time ago now. And I completed my MEng in 2018. So I actually went back to the industry and then I came back to MIT to finish my MEng.
So I was 14. Isabella and I met back when we were freshmen. After school, we went to work for a number of companies. I worked at Facebook. Isabella worked at Slack for a while. And then we joined forces to start Tangram together. And our mission is to make it really, really easy for software developers who aren't machine learning experts to train machine learning models, add them to their applications, and monitor them in the real world. And as part of this, we will be happy to show you guys a demo and talk a little bit about what we're doing and take as many questions as you want. Cool?
Yeah, cool. So if you guys want to start with the demo and then we can take questions after.
Yep, sounds
Sure,
great.
sure.
Great.
All right, so I'm going to share my screen. And can everyone see where I'm at on the command line?
Yep, looks good.
Cool. So again, what we're trying to do is make it really convenient for developers to train machine learning models. So we'll do that right here on the command line. Here in this folder, I've got this data set. It's an example data set where each row represents a patient in a hospital, has information about them like their age, their gender, their cholesterol, et cetera. And then the last column over here is called diagnosis. It's either negative if someone doesn't have heart disease or positive if they do. And the goal is to train a machine learning model to predict whether someone has heart disease or not based on all the other factors. I can do that without cracking open a Jupyter notebook, just by using the Tangram command line tool. So I'll say Tangram train. I'll pass in the path to that file and specify the name of the column that I want to predict. And when I run that, what happens is the command line tool automatically, at its default settings, infers the types of all the columns, performs feature engineering, and trains a bunch of machine learning models across a range of hyperparameter settings. And it writes the best model to this file here, heartdisease.tangram. This file contains everything you need to make predictions, not just from Python, like you might be accustomed to, but from any programming language, like JavaScript, Go, Ruby, even Elixir. What else do we have? Rust, yeah. So here's an example that we've written in JavaScript. So to make a prediction, all I have to do is load in the Tangram library. Then I can load up the model from that .tangram file, and then I'll make an example input. So here's just something that's hard coded. You provide here I'm like providing the age of the person, their cholesterol, et cetera.
And anyone who's done machine learning in a Jupyter notebook knows that in order to train a machine learning model, you need to turn your raw data into features that the machine learning model understands. For a linear model, this means taking the age value 63 and normalizing it. For a gradient boosted decision tree, if you have the string here, typical angina, you'll probably label encode this. These are each enum variants. You'll label encode it. For a linear model, you'll take it and you'll one-hot encode it. This is all abstracted away by the Tangram library. So you don't have to worry about that as the developer.
And the last thing you do is you just say model.predict, pass in that input, and we can run it. And it makes a prediction. And what's really cool here is that you don't have to stand up a separate server. Usually what people have to do is you develop your model in Python, and then you have to run some sort of Python server to serve predictions back to your normal programming language, the thing where you write your application. Like if you're writing a Node.js app or a Ruby on Rails app, what you can do with this is you can just include it right in that application. So, machine learning is just an NPM install or a gem install away. Cool. Can we take any questions at this point? See if there anything people are wondering about?
Yeah, I'll wait for some live audience questions to come in, but in the meantime, one question I have is, I think so. I've only taken like an introductory, machine learning class, but something I realize is that, a lot of these things like Jupyter Notebooks, Google Colab and stuff, they tend to run pretty slow, especially when the data set is large. So I was wondering for you guys, it ran really, really quickly. So if you guys could touch on, how you tried to improve that experience, especially for developers who, are not familiar with how much energy goes into machine learning.
Yep, that's a great question. So the data set that we just trained is pretty small. It's 300 something rows, but we also focused really, really heavily on making extremely performant machine learning algorithms. So we wrote the core machine learning algorithms in Rust, and we have some benchmarks to share that David's pulling up. We benchmarked our gradient boosted decision tree library against the leading gradient boosted decision tree implementations of LightGBM, sklearn, and XGBoost. And we have the fastest training time and the lowest memory usage. So on the performance side, sklearn models are pretty slow, XGBoost models are pretty fast, LightGBM models are pretty fast, and Tangrams models are fast. If you have a very large data set, it will take time to train. So one thing that we also wanted to do is make it really convenient for the developers to pause training or stop training at any moment. So let's say you're in Epic 500 out of 1,000 and you're kind of sick of waiting and you just want to see what the best model is. You just say Control C in the command line and you get the best model trained so far. It'll stop training at Epic 500 and say, okay, let's just evaluate this model and say it's good enough. And you can train again later if you feel like it'll get better. You can look at the loss curves.
Yeah. One issue you probably run into with all of those, Google Colabs and stuff is that they provision really crappy small servers for you. So that's definitely that's definitely part of it. But then the other part of it is that there's this massive machine learning stack built on Python, and there's a lot. Even though the core number crunching at the bottom generally is written in C and exposed to Python, there's a lot of Python on top that runs quite slowly. And so the result is that a lot of performance is left on the table. So with Tangram, everything's written in Rust. You can find it on GitHub. And so every part of the stack is very fast. And so that's part of why we're able to make it run a lot faster.
Wow, yeah, that's amazing. And definitely like shows how much focus you guys have for developers. I know like I myself, if I was put into something and wanted to use machine learning, this is definitely like a tool I would love to use. Yeah, so I think one question that we've gotten is why did Tangram choose Rust over C++?
It's a great question. There are a couple answers. One is since we are just a very small team, having a language that is memory safe means that we don't have to deal with seg faults. We don't have to deal with all the memory unsafety issues of C++. It was a lot faster for us to develop a larger code base where we could potentially break things. That's number one. And another part of it is that, as you'll see in a little bit, it's allowed us to use one programming language across the entire stack, from the machine learning algorithms to the CLI, and then also, what we'll show you in a moment, the web application.
And Rust build system.
Yeah, and then on top of that, all the benefits of Rust, which is having a very good build system, which makes it very easy to compile, to use third-party libraries and compile for a range of platforms.
Okay, great. Yeah, if you want to continue with your demo now. With the...
Okay, so where we're at here is, we've trained a model, we've integrated into our application, all's well and good, right? But you have no idea if this model is worth anything, right? This command line tool just spat it out. So what you can do is you can run the Tangram app on the command line. You can just say Tangram app to run it locally, or you can use the hosted version at app.tangram.dev. Let me jump over to that. And what you do is you take that .tangram file and you upload it, and then you get this whole report that explains to you everything that just happened. So you can see the training loss per epoch. You can see the feature importances. I can go to the grid here and you can see the full hyperparameter grid. So these are all of the models that were trained, only one of which was chosen, the highest performing one. So I'll choose one and you can see all of the hyperparameters.
So the goal is that this is not a black box machine learning system. We really tell you exactly how every single model was trained and give the developer all of the insight into the accuracy of the model, the PR curve, the ROC curve.
Yep. So there's all of the most important metrics, accuracy being the most obvious one, but there's precision, recall, confusion matrix, PR curves, ROC curves. These are all the things that a professional data scientist would produce in a Jupyter notebook to present to product managers and other people in a company to convince them that the model is worth putting into production.
And we just automatically do it so that you don't have to worry about doing it yourself.
We have this cool page called tuning, where you can tune your model to your preferred trade-off between precision and recall. So in this case, what we're doing is we are predicting whether someone has a disease or not, right? So it would be really bad if we tell someone that they're healthy when they actually aren't, because then they might go about their normal activities and then have a heart attack or something. However, if we tell someone that they're sick, even though they're actually healthy, well, then they get a bit of a scare, they go back in for some further testing and maybe everything's okay. So what we can do is we can use this we can drag this threshold slider and watch how the metrics, particularly precision and recall, change. So if I drag it down, what I see is that I can sacrifice 16% on precision, but gain 15% on recall. Mm-hmm. And that may better satisfy my trade-off. And yeah, go ahead.
Yep. Oh, I was just going to say, like, if anyone has trained a binary classifier, the output is a probability between 0 and 1. And what we're doing here is just saying, like, okay, let's change the threshold to 0.28. Anything over 0.28, we're going to say that person has heart disease. Anything under, we say they don't. And as you drag the threshold, we tell you how your model's metrics change based on if you had set the threshold at that value instead. So this is just like a tuning thing for if you feel like in your particular use case, you want really high recall, you can play around with that.
So then the last part is what happens in the real world when you're actually making predictions on patients. What you can do is you can track every prediction. So the libraries for every language let you log back all the predictions back to this app. You can pick any of your real predictions. You can look at the input, see the output. And then we have this cool chart that shows you an explanation. It explains to you why the model made the decision it did. So in this person's case, you can see how due to their gender, they were more likely to have heart disease, but due to their age, they were less likely. So this person is probably relatively young and probably male. And I can check that. Yep, they're male, which made them more likely to have heart disease and relatively young.
And this is the chart here is like an area of explainability that is getting more and more popular these days because people don't want to just ship models and not have any insight into why they're making predictions. So one thing that people used to do was only use linear models because linear models are very straightforward. You just read the weights and you understand how the model made a decision. With gradient boosted decision trees, they're very complex models. You don't have this easy introspection into why it made a particular prediction. And so there's all these new explainability methods that have come out. One is SHAP, another one is LIME, and they're really great methods to explain how the model is thinking. And that's what we've incorporated here.
Yep. So the other thing that you can send back up to the app is what we call true values. It's the eventual outcome. So in this case, it's whether someone ended up getting heart disease or not. And then what you can do is you can track your model's accuracy in production. So here we rigged this demo so that the accuracy would be lower in production versus training. You can see how the green is production, tracking well underneath the training accuracy. I probably want to figure out why. So I'll go to stats and I will see if there's anything up with some of my columns. So this column called chest pain has an alert next to it. I can click that and see what's going on here. And what I can see is that for each of these three unique values of chest pain, training in blue versus green in production are quite similar, but this one has a huge discrepancy. If I scroll down, I can try to see why. It looks like under invalid values, there's this strange value ASX, which is making up about 25% of the predictions. Apparently, this is how some doctors abbreviate the word asymptomatic. So what I could do is I could just add to my code a little thing that says if ASX, then map it to asymptomatic, or I could train a new model. Either way, I may have found the cause of the problem for the model in production.
So basically the goal of Tangram in summary is to embed best practices for machine learning into a vertically integrated all-in-one machine learning solution. And this is our V1 of that.
We'd love to take some more questions.
Yeah, so we talked a lot about how you're using Tangram to look at heart disease as an example. Do you have a few other examples of how people have been using Tangram to train on different models? Like, for example, one big example that I can think of off the top of my head is the COVID-19 pandemic. Do you have examples on things like that and how those turned out?
We don't have any COVID-19 use cases, but we do have some use cases that I think we can talk about.
Go ahead.
Should we talk about Atlassian's use case or
Sure. Yeah.
what's most interesting, you think?
I have drafted at last. All of them are good. Go ahead.
Okay, and we can show the example.
Yeah, we can definitely show the
Okay,
example.
so we have a team at Atlassian, and they're trying to predict the programming language contained in a code snippet. So they have people writing code in Confluence, and they say that like 80% of people don't select the programming language, and so there's no syntax highlighting. And a front-end team there wants to automatically detect the programming language and then apply the syntax highlighting for that particular programming language. And as you guys start working in industry, you'll realize that a lot of software problems boil down to organizational problems. So this team, this front-end team originally had a plan of giving it to the data science team to train a model. And the data scientists came up with a model. And then they said, okay, well, how do we get this into production? So then they went to the back-end team, and the back-end team had to coordinate with the front-end team to expose an API endpoint. And they also had to coordinate with an ops team to stand up a separate server. And the front-end team said, okay, well, this is not going to work. There's just way too much coordination here. So we need a solution for deploying a machine learning model directly in our React front end. And so they found Tangram, and they incorporated this model to predict the programming language directly in their front end React application. That's one use case. Do you want to talk about the drafted seniority use case?
Sure. So there's a small, in general, Tangram is designed to cater well to smaller companies that don't have large data science and machine learning teams. So at one company that's been our design partner since the beginning of the year, they want to help match job candidates with job openings. And so they have a number of models that all come together as part of that process. I can actually show you one of them uploaded to our app here, and we can play around with it. So what this model does is it predicts what someone's seniority level is based on their title on LinkedIn. So it rates them on a scale from 1 to 8, where 1 would be some intern and 8 would be something like CEO. So we like to make fun of my older brother, who has a very superfluous title. So we can enter in his title. And you can see that his seniority is 6 out of 8. You can see
the
that
model is very confident.
Yeah.
Of this.
And if we look at the explanation, you can see how it kind of like breaks down why the model made that decision. So because he's a director, pushed his seniority level way up, but because he's missing the word executive, he got bumped down. So those are just 2 small examples from users, how they're using this.
Wow, yeah, and definitely I feel like, especially as machine learning grows more popular with developers, it's definitely going to grow as well. I think as you talk about use cases, another question came in. Do you see Tangram as contributing to research on machine learning interpretability, and or more of a tool for data scientists, machine learning engineers, etc.?
Great question. So we currently are targeting, I don't know if I'm going to interpret this question correctly, but we're currently targeting software developers. And we've had a lot of interest to expose training to Python so that we can also have data scientists and machine learning engineers using Tangram. Do you want to pull up the config file?
Yep, sure.
So with Tangram, you can configure every single aspect of training. And you can say the column types, you can say how much you want to hold out for comparison, how much you want to test, what percentage of the data you want for testing, and also all of the hyperparameters of each of the underlying algorithms, machine learning algorithms. So if you know what smoothing factor for discrete bin sorting is, by all means, you can tune those parameters. And so what we want is for Tangram to boil down at the lowest level to something like the sklearn API, so that it is usable by data scientists and it's not just a toy tool that works well for simple use cases, but doesn't support the advanced use case. In terms of interpretability, we are using interpretability methods that have been developed by other researchers. We've just incorporated them into our app.
The primary goal here is to kind of codify in software a lot of the best practices that have developed regarding machine learning. Whereas today, everything is done very ad hoc. And so a lot of companies have to hire experts. We expect that in the future, rather than having to hire these people who are very rare and command high salaries, instead companies will be able to use software that has all the best practices baked in.
Yep. And we're also, like, on the maybe more researchy side, we're really interested in providing Rust implementations of core machine learning algorithms. And we think that there is going to be a movement into writing these core ML algorithms in Rust, just like they are now in C, C++. They will be written in Rust, but then exposed to Python. So a Python developer in a Jupyter notebook will never know that the underlying algorithm is actually written in Rust. They'll just be interacting it through Python. But we think that the language features of Rust will lend itself to more and more developers wanting to write these types of algorithms in the language. Anything else?
Speaking of codifying best practices, actually, one question that came in is that bias in training data has been a large problem in recent years with regards to machine learning models. So do Tangram models make any adjustments for inherent societal bias?
So the command line tool, when it runs, it checks, it runs a number of checks on the data to look for common errors. But it's definitely an area we want to get into to make them even better, to address, like you mentioned, societal problems, bigger issues. Right now, the checks are very rudimentary, but we absolutely plan to perform more extensive checking like the questioner described.
Yeah, that's great to hear. I also just wanted to, if you guys have more to demo, I'd love to see that. If not, I wanted to pivot more into you guys and your story with Tangram. Kind of just what inspired you guys to create it, and how did you guys kind of come together to, start this startup together?
Yep.
So we're all set demoing, so I'll stop the share. Go ahead.
Yeah. So why don't we talk about like where Tangram started?
Mm-hmm.
So I was a machine learning engineer at Slack, and we had a bunch of people asking us about adding machine learning powered features. And our small ML team was writing Spark ML models. It was very much something that a steep learning curve to get a machine learning model into production at Slack. And so we just had to turn these teams away, and we didn't have the domain expertise of their particular problem area that they wanted to solve.
So I worked at Facebook, and the way it worked there is that for every team of about 5 or 6 backend and front-end developers, there was at least one machine learning engineer and one data scientist. This allowed all of those teams, for every little corner of the products that they worked on, to add machine learning powered features. But Facebook is a very special company. They have a lot of money. Most companies cannot afford this. And so most companies are more like Slack, where there's either a central machine learning organization, or in many other companies, none whatsoever. So when Isabel and I were discussing our experiences at work, we came to the realization that there's an opportunity to provide machine learning tools that kind of mimic the model that was at Facebook and solve the problems with the model that was at Slack, by giving regular developers, people who do Node.js, people who do Ruby on Rails, et cetera, the ability to train and deploy machine learning models on their own. And there's a lot of historical precedent for a movement like this. For example, long before any of us were born, when companies wanted to use databases, they had to hire database experts to do a lot of low-level programming. But today, any one of us can download MySQL or Postgres, turn it on, and talk to it with SQL. And there's actually a tremendous amount of magic hidden behind that database. Things like write-ahead logs, B-tree indexes, query planners, et cetera. All things that we as developers don't really need to know about.
And you'll learn if you take Sam Madden's class.
Yeah.
But otherwise you probably won't think about it.
You probably don't need to think about it that much. And so we expect that in the future, most developers will be able to use
machine learning.
Exactly. They'll be able to use it like they use databases. That's not to say that you don't need some level of expertise. Even today, most companies that use databases, they still have to crack open the Postgres manual, learn about some obscure settings and start tweaking them a little bit.
Create some custom indexes, especially these very large companies that need really to get the most performance out of their databases. They do that.
But the entry point is relatively low friction. And so we would like in the future for the entry point to be better than what it is today, which is NumPy, Pandas, scikit-learn in a Jupyter notebook.
I can talk about my PHP story.
Yeah, go ahead.
So this is something that's kind of funny anecdote. One of the reasons we were so keen on making prediction available in more programming languages because of something that I experienced at Slack. So we discussed with the ops team there whether we could have a separate server to host our machine learning models. And
so that they could be Python or Scala.
So they could be Python or Scala. And they're we don't really want to support another service. So figure out how to do it in PHP. And we're like, okay. So we didn't have any way of doing XGBoost in PHP. So we ended up training linear models. We copy pasted the weights of the trained linear model. We put them into PHP. We wrote the sigmoid function in PHP, and model versioning was a comment on top of those weights. So it's like a very different story when you're actually boots on the ground trying to get something deployed in a large organization versus the rosy picture of like everything's great with XGBoost, like it'll just work fine once you're actually on the ground and you realize like the organizational overhead of doing these things is very high.
Yeah, definitely one of the lessons is post MIT, you think that you're entering a world where everything is done extremely professionally, but really it's just a big stack of hackathons. One after
or
the
like
other.
You would expect that like everyone has like the craziest like GPT-3 models in production.
When what most people need most of the time is a linear model and sometimes a gradient boosted decision tree for the more advanced cases.
For tabular data, not for image and audio.
That's right.
Right. Yeah. And I think as you were talking about it, I definitely thought of like some other examples of, languages or like you said, softwares that kind of became standard, in the developers industry. So I'm just curious, in terms of future plans for Tangram, then, are you looking to kind of scale your application now so that, more of these bigger companies like Slack could use this and implement this in their business model? Or are you kind of gearing this more toward, consumers and, people who are just people who are developing apps or developing startups, at that smaller scale?
Are they our investors? Is this a trick question?
Oh, sorry. I'm just really curious about it and I know a lot of our.
It's a great question. I think the answer is somewhere in the middle, which is where we're looking at Tangram is designed and suited best towards small to medium sized companies. So in startup parlance, that would be companies that are between the Series Seed and Series B stage. So these are companies that might have anywhere between, say, 0 and 100 employees, and that have limited capabilities when it comes to machine learning, but a lot of data and great ideas for adding machine learning powered features to their apps.
But what David described here for Series B companies also exist. These kind of teams that are not very mature in their machine learning platform exist in large corporations. They're small teams, they're disjoint. So it's kind of an open question whether to go after them as well. And I think for now, we're going after both.
Yep.
And we'll let the market tell us.
Even though a lot of large companies have established machine learning practices, that doesn't mean that it extends to every application of machine learning within the company. In fact, in most large companies, for every problem that you might solve, there are 10 different ways of doing it that are done in 10 different areas of the company. And so there's always a good place for easier to use tools, even in larger companies with more capabilities.
Right, definitely. Yeah, I think everyone in our audience, I can speak for everyone at Hack MIT and in our audience today, that we are all very interested in startups and entrepreneurship. This is one of the reasons why we're super excited to have you guys here this weekend. Yeah, so I think we're going to wrap up pretty soon, but to end it on a high note, Hannah, do you want to ask some fun questions that we've gotten from the chat?
Yeah.
I guess one very interesting question. I guess to start off slightly more seriously, do you have a favorite class from MIT that you really enjoyed?
Well, I think we should both answer this independently. So I'll let Isabella go. Are
No,
you ready?
you go first.
Oh yeah, I can go first. So
Mine's a really bad answer.
I was course 6-2. I love this question, by the way. It's a great question. I was course 6-2, and my, I guess, two favorite classes were 6-115 and 6-131. And for anyone who is interested in getting their hands dirty with electronics, I couldn't recommend them more.
I really liked 6046, and now I'm going to go running.
So for anyone who, so I guess Isabella and I are then polar opposites.
Yeah, Isabel, I'm going to assume that you were a 6'3", not a 6'2".
David was 6'2".
Cool. Yeah. Yeah, I think Hannah, do you want to ask one more question?
Sure, yeah. I guess one good question that came in, sorry to drag this out a little bit more.
No, please, we love the questions. They're great.
Yeah. So someone asked, you mentioned automating the machine learning modeling process as an important mission for Tangram. Do you also think it's important to have the human touch as part of this process as well?
So we don't want to use the terminology automating the process, because there are a lot of companies that have promised to automate the process with very poor results. And so we would rather reframe it as having good defaults.
Yep.
Yeah, go ahead.
So you did say automating though. I'm going to check you in the demo.
Okay.
Yeah.
Uh-oh.
Yeah. So you walked yourself into that. But the goal is to be like Ruby on Rails. So you have really great defaults, but you have full customizability. And that's kind of like a guiding principle for us, is we want it to be really easy to use, but then also allow anyone who has advanced knowledge to configure every aspect.
So just as flexible as existing machine learning tools, but with a layer of very sane defaults built on top, if you don't want to know the inner details, which people already use, by the way. You know, most people who use XGBoost to train a gradient boosted decision tree have no idea what most of the parameters are, and they just leave them at the defaults.
Yep. So we're kind of just one little level of defaults on top of that.
Exactly.
Yeah, that definitely makes sense. I think something I've definitely experienced working with applications, Hannah probably can also speak to this, is using third-party applications and not being able to customize it. So I think seeing your demo and seeing how much customization that you guys put into it was definitely really, really helpful. And as a developer like ourselves, we would definitely love those features. Yeah, so just to wrap up this fireside chat, thank you guys again for joining us. And thank you again to the live audience and everyone here on Zoom who's joined. And yeah, look out for Tangram, who will be here in person at MIT this weekend at Hack MIT. And they will also have a virtual booth at Gathered Town if any virtual hackers would also like to come talk to them. They'll also be
Yes, most important thing.
All for the likes.
Yeah, and also, you know, we'd be honored if any of you would be interested in using Tangram as a part of your hack. And there's a sponsored challenge for the best hack using Tangram.
Right. Yeah, so I encourage all the hackers here who are interested in Tangram to check it out. And hopefully this demo was really helpful for you guys as well. Yeah, so we look forward to seeing you guys again this weekend and seeing your events there.
Awesome. Looking forward to it. See you this weekend.
Yeah,
Thank you so much.
Bye.
Bye-bye.